First-generation computers, 1940 to 1956. The story of computers begins in the 1940s with what are known as first-generation computers. These machines were built using vacuum tubes, which were large glass components used to control and amplify electrical signals. Although revolutionary at the time, vacuum tubes made computers extremely large, expensive, and inefficient. They consumed huge amounts of electricity, generated excessive heat, and required constant maintenance. Programming was done entirely in machine language, meaning instructions were written in binary form using ones and zeros. Despite these limitations, first-generation computers proved that complex calculations could be automated and laid the foundation for modern computing. Examples of first-generation computers include ENIAC, UNIVAC 1, and IBM 701. Second-generation computers, 1956 to 1963. The second generation of computers emerged with the invention of the transistor, which replaced bulky vacuum tubes. Transistors were much smaller, faster, more reliable, and energy efficient, leading to significant improvements in computer performance and durability. Heat production was greatly reduced, and computers became more compact. This generation introduced assembly language and early high-level programming languages such as Fortran and COBOL, allowing programmers to write instructions more easily. Computers began to see wider use in business, science, and industry. Examples of second-generation computers include IBM 1401, IBM 7094, and CDC 1604. Third-generation computers, 1964 to 1971. The third generation marked a major advancement with the development of integrated circuits, also known as ICs. Instead of using individual transistors, multiple electronic components were placed on a single silicon chip. This innovation drastically increased processing speed while reducing size and cost. Computers became more reliable and were capable of multitasking through the introduction of operating systems. User interaction improved with the use of keyboards and monitors, replacing punched cards. Third-generation computers became widely adopted in universities, research centers, and large organizations. Examples of third-generation computers include IBM System 360, PDP-8, and Honeywell 6000 series. Fourth-generation computers, 1971 to present. The fourth generation of computers began with the invention of the microprocessor, which integrated an entire central processing unit onto a single chip. Using very large-scale integration technology, thousands and later millions of transistors could be placed on one processor. This breakthrough led to the development of personal computers, making computing affordable and accessible to individuals and homes. Computers became smaller, faster, cheaper, and far more powerful. High-level programming languages such as C, C++, Java, and Python became widely used. Most modern devices today belong to this generation. Examples include the IBM PC, Apple Macintosh, desktop computers, laptops, and tablets. Fifth-generation computers, present to future. The fifth generation of computers focuses on creating intelligent machines capable of learning and decision-making. This generation is driven by artificial intelligence, machine learning, natural language processing, and quantum computing technologies. Instead of simply following programmed instructions, these systems can analyze data, recognize patterns, and improve over time. Parallel processing and ultra-large-scale integration enable extremely high performance. Although still evolving, fifth-generation computers are already reshaping industries such as healthcare, robotics, finance, and scientific research. Examples of fifth-generation computers include AI-powered systems, quantum computers, advanced robots, virtual assistants, and modern supercomputers.